at more stuff for inverse. Okay, I'm going to skip these first two because I think you guys can plot points and opposite points. I'm more worried about this. Okay, number 2. All right, if we're given the table where x is 0, 1, 2, 3, 4, and y is 3, 1, 2, 4, 2, how am I going to find the inverse of that? You guys remember from way long ago? I mean, you're literally just switching them. So for where it says y, you're going to write all these in for the x's. 3, 1, 2, 4, 2. And then you're going to write all the x's in for the y's. So 0, 1, 2, 3, 4. So it should be really easy. You're just switching them. Okay? Now, is this example of an inverse a function? Why? It's not. The answer is no, but why? So let's look at the x values. Is there more? Is there any of these x values or any? Listen, I'm teaching up here and recording. Shut up. Any of these x values the same?
Yes.
So does 2 have 2 different answers?
Yes.
We can't do that for a function.
So it's still no.
So the answer is no. It's not a function.
1 and 1.
Okay. 1 and 1 doesn't matter because there's only 1 in the x values. Okay. All right. Number 3. We're going to graph the inverse of this. I think it's helpful to list the ordered pairs, like it said. So I picked some from this graph that are like exact. Okay? So if I go right here, I can see that crosses at exactly that point. This one crosses at that point. This one crosses at that, right? So I picked those 3 because I feel like they cross perfectly. Does that make sense? So at -2, I'm at -2. At 0, I'm at 0. And at 2, I'm at 2. Okay? So, we've got to draw the inverse of this. But look, do these all match on the opposite side? So, let's do one more that might not be exact on here, just to see if it's any different. Okay? So, let's just like look at 1. What does -1 look like it is? If we're at -1, it's below it's below 0, right? What do we think? It's at like -0.25 or something like that? Like a quarter? Okay, let's look at 1. What do you think 1's at? About a quarter, right? Okay, now when we're reversing this, we're simply going to graph all the y's as x's. So you can rewrite this if you want, that's fine. If you want to do the inverse, you can literally go at -2, you're at -2. At -0.25, we're at -1. At 0, we're at 0. At 0.25, we're at 1. And at 2, we're at 2. Or if you're like, I can figure out to graph these first, you don't have to rewrite it if you don't want to, is what I'm saying. So at -2, I'm down here at -2. But at -0.5, I'm at -1. 0, I'm at 0. 0.25, I'm at 1. And at 2, I'm at 2. Okay? This is more to show you that it did change. So it doesn't look very different from this, but that point, these 0.25s right here were really important to see that it actually did change. Is this an example of an inverse function? Now we're looking at a graph instead of a list of numbers. So for a graph, we do something called the vertical line test. If we took a straight up and down line, and I like to use like a pen or pencil to do this, if I run this straight up and down, is there anywhere that it crosses that twice? No, so it's a function. So yes, it's a function. Okay, for number 4 and 5, we're just going to do some more inverse function stuff, which we've done before, but it's been a while. So I want to prove that these are inverse functions of each other. What I'm going to do is simply switch where x and y go. So first I might want to think about f of x is really what letter? If we're going to graph this in a graphing calculator, it's y, right? So y equals x plus 2. So now I'm just going to switch the x and the y. So I'm going to say x equals y plus 2. Now I want to get y all by itself. What am I going to do to get y by itself?
Subtract 2.
Minus 2. So x minus 2 equals y. Is that this? Are those the same?
No.
That says x minus 2. Does that say x minus 2?
I'm sorry.
So then that is an inverse. So just to double check, because we want to know that f and g are inverses of each other, you could do it the other way too, where you got y equals x minus 2. Now you're going to change it. So this is x equals y minus 2. Then you're going to add that 2 to both sides to get y by itself. Are these the same thing? Right here in the box?
Yes, ma'am.
Yeah, so they are inverses of each other. Okay? All right, let's try one that's just a little bit harder. So we've got 4x minus 1. So remember, the first thing we're going to do is change it to y. Then what's my second step?
You have to add 1.
Before that,
You have to switch
x and y, right? X equals 4y minus 1. Now we want to get y by itself. So then we're going to add 1.
Add 1.
So we get x plus 1 equals 4y. How do I get rid of that 4?
You divide.
Divide. Because it's being multiplied, I'm going to divide. And that gives me x over 4 plus 1/4 equals y. Okay. Let's do it in the other direction. Remember, the first thing we're going to do is say it's y equals 1/4 x plus 1/4. Next, we're going to switch where x and y go. So we get x equals 1/4 y plus 1/4. Now what do I do?
Now
We switched them.
Oh,
Now we're going to
subtract.
subtract. X minus 1/4 equals 1/4 y. Okay. It's times 1/4, so we want to find the reciprocal. 1 over 4, the reciprocal to that is 4 over 1, right? Times this by 4 over 1, times all this by 4 over 1. These cancel, and I'm left with y equals 4 times x is 4x. 4 times negative 1/4 is just negative 1. So I know some of you get mixed up with fractions. If you're having trouble with fractions, remember each of this is worth part a step, okay? So if you do this step, that's worth some points, okay? If you can subtract that 1/4, that's worth some partial credit, okay? And just make sure you distribute. If you don't remember that 4 times negative 1/4 equals negative 1, you can put that in your calculator. You know, you just put 4 times negative 1/4, and it'll give you the answer is negative 1. All right, let's turn it over. All right, I want you guys to try number 6 on your own. First answer if it's a function. If you need to list ordered pairs, that helps me sometimes. Find the other one. I'm going to give you about 2 minutes. Actually try it. If you're not trying it, you don't know if you know how to do it or not. Okay, so we should have said, yes, this is a function because it passes that vertical line test. And we can list our ordered pairs as like -2, 3 is a good one. -1, -1 is a good one. 0, 1 is another one. And 1, -3. And then I would simply switch those, so we should have 3, -2, -1, -1, 1, 0, and -3, 1. And so it should be, we go over 3, up, down -2. Oh, sorry, this is 1, -1. We go over 1, down 1. This should be negative, I messed this up. -1, 0, and -3 should be 1. And yes, it is a function because it passes that vertical line test. We feeling okay about this?
No.
No?
I'm getting there, but no.
Okay, so I don't want to spend a lot more time on this, so I'm going to give you guys a choice. Do you want me to do number 7, or do we want me to do one like 9, 10, 11, 12, 13, or 14? So I'd like to do 1 or 2 more problems. Which do you guys feel like you need? Do you want me to do like 7, or do you guys think you got that? Or do you want me to pick one from the bottom? Bottom? Okay, which one do you want? Like number 12? Okay. All right, so we need to find the inverse of f. Number 10? Because it's got that fraction in there? Okay, so I think I should do 10 and 13 because you guys always get messed up when we take something to the third power. So let's look at 10. Shh. The first thing I'm going to do is make it y equals 1/2 x plus 4. And then I'm going to switch x and y. Okay. Now I'm going to subtract 4 from both sides. X minus 4 equals 1/2 y. And now I'm going to multiply both sides by 2. So I get 2x minus 8 equals y. That's it. Okay, let's look at number 13. I'll do 11 in a second. Let's look at 13 and I'll try to make it slower. You ready? Shh. You guys always get messed up when there's like something to the third power. So let's do this one together and I'll go slower. What's the first thing you want to do? Shh. Focus up here. I've got 2 more problems at most to do. Shh. Y equals x to the third plus 3. What do I do next? Change them. Good. So I get x equals y to the third plus 3. Is everybody with me so far?
Yes.
All right, what do I do next? Minus 3 on both sides. Good. So we get x minus 3 equals y to the third. What do I do now? Not the square root, but the third root. Third root of both sides. So now I just have y equals the third root of x minus 3. Yeah? Okay, do you want to do number 11? Because it has that weird divide by something? Okay, what's the first thing I'm going to do? Y equals x minus 2 over 3. Now what do I do? Change them. So it becomes x equals y minus 2 over 3. Now what do I do? Multiply by 3. Good. So we got 3x equals y minus 2. Now what do I do? Plus 2 on both sides. Yep. 3x plus 2 equals y. Or y equals 3x plus 2. Good? All right, guys, why don't you go ahead and try the homework. The back page, this stuff right here, you guys messed this up on your last quiz where it's the composite, and it'll be on the test. So if you are still unsure how to do this, we should practice. We might do this after the quiz or before the quiz. Okay? All right. Go ahead. You have the rest of the hour to work on your homework.